All right, so we started the 2-6-2-7 blend. We really talked about 2-6 on Friday, which is graphing with vertical and horizontal asymptotes. So when you're dealing with a graph, and they're kind of all going to get looped together on your test. It's going to say test for vertical asymptotes, horizontal asymptotes, slant asymptotes, find your zeros, find your y-intercept, graph it. So you kind of need to gather as much information as you need to graph it. So for number 1, it says to find the vertical horizontal asymptotes and then graph the function. So I'm going to go into as much detail as the test will ask you to do, which is more than just those, but you need those to graph them anyways. So the first thing you want to do with these is make sure that you cannot reduce them. So the numerator here is not factorable and I can't cancel anything out. Though that's the scenario in which a hole would be created. And that doesn't happen here. So I don't have to worry about a hole for this one. I'll go over the one in the homework that did have the hole so we can refresh on that. But just keep that in mind as you're working through these, that's the first thing you want to check for. Then to get the vertical asymptote, what do we do?
Set the bottom equal to 0.
Good. Set the denominator equal to 0. So you have two choices with this one. You can either factor it or you can use the even root property. Either way, you get x plus 4, x minus 4, and then x equals -4 and x equals +4. And I'm going to say it again. I'm going to say it almost every time we have this question, that it has to be equations with the hopes that you guys will remember that. If you do not have the x equals, it's wrong, and please don't do that, okay? It's an equation because it's a line, so it has to be there. Then the second thing we're going to find is the horizontal asymptotes, and for this, we have to pay attention to the biggest exponent in the numerator and the biggest exponent in the denominator. This time, there's only that exponent, but if there was more than one, you're looking for the highest. So what's the case? There's 3 cases, right? If the exponents, if the one in the numerator is bigger than the one in the denominator, then what's the case there? Bigger in the top than the bottom is none, okay? Bigger in the bottom than on the top, so the top is smaller than that. This is your y equals 0. And then a case like this one where they are equal, this is your leading coefficient of your numerator over the leading coefficient of the denominator. So leading coefficient being the number that's on the front of those highest exponents, which in this case is 4 and 1. And that tells you that the leading coefficient here would be 4 over 1 or y equals 4. And again, that's a y equals. It has to be a line, so it has to be an equation. Everybody with me so far? Yeah? Okay, then I'm going to graph what I already have. So I've got the x is +4, -4. And the y is 4. So I know I have 3 areas of which I need to plot points. I need to do something to the left, something to the right, and then something in between. So one of the ways that you can get those points is by using your intercepts. It's going to ask you for your zeros and your y-intercepts anyways. You might as well find them. So for the y-intercept or for the x-intercept or the 0, which is how it will be worded, I set my numerator equal to 0. I divide by 4, and then I'd square root, getting plus and minus the square root of 0, which is only 0, but what does that tell you, that plus and minus? There's 2 of them, which means it's going to bounce at that point. So I have a point here, and my graph is going to bounce. And I'll show you how you could get that if you didn't figure it out, but you definitely have a point there. Then you want to find the y-intercept. So if I do y-intercept, I will plug zeros in for x. Y would be 4 times 0 squared. 0 squared minus 16, and I get 0 over -16, which is still 0. Which makes sense because that's what my other point is. Now pay attention because when it says zeros, we list these, right? So the 0 is just 0, or x equals 0. But the y-intercepts we give in coordinate point format. Don't lose points on silly stuff like that of the formatting of the answer. So when it gives you the 0 in the line, you're just putting 0. When it gives you the y-intercept, you're putting 0, 0. So this means I don't have enough information yet to plot what's on the outside. I do know that this is symmetric, but not everybody's going to pick up on that, which means whatever's happening on the right is happening on the left, okay? But if you don't pick up on that, then you just plot some points. So I'm going to take something from the left of the -4, like -5, 4 times -5 squared over -5 squared minus 16. 4 times 25, 25 minus 16, 100. Over 9, which is 90, or 9, sorry. It's 9, no, it's 11 and 1/9. Okay, So I know my point is all the way up here. And my curve is doing that. So then again, symmetry helps me by saying that whatever's happening on the left there is probably happening on the right. If it is symmetric to the y-axis like it is, I know it is. But if you're unsure, then you're going to plug in something to the right of positive 4. So I would plug in 4, 5 squared minus 16, 4 times 25 over 25 minus 16. I get the same answer. So I know my point is up here. So as far as your graph goes, test-wise, you need both vertical asymptotes, you need the horizontal asymptote, and you need the curves with at least one coordinate point in each range. If you were unsure about the bouncing that's happening in the middle there, then all I would do is plug in a point from this area, like plug in positive 1, and this area, like negative 1, and then I would see what that curve does. Because remember, sometimes the curve in the middle looks like a cubic shape, okay? This one was a parabola, but there can be ones that look like cubics, and then the outsides ones, actually one goes up, one goes down in that case. Any questions on that one? So obviously you're going to have graphing asymptotes and all that stuff on your test, which is Thursday. Okay, so I'm going to repeat that just because I didn't get it on the video before. Okay, I'm going to add domain onto these functions. So remember that domain is the same x values as your vertical asymptotes, but the vertical asymptotes, we say that that's what x equals, whereas the domain, we say that that's what x cannot equal, right? So it can't equal negative 4 and a positive 4, and then I want that answer written in interval notation. So it goes negative infinity to negative 4, negative 4 to positive 4, and then 4 to positive infinity. So the same values, because you're setting the denominator equal to 0, except that it's equal to 0 for vertical asymptotes, it's not equal to 0 for domain, okay? Questions on that? Okay, so these are some of the questions from the homework that came up. This one said, find the domain, decide whether it's continuous, identify the horizontal asymptotes, and then vertical asymptotes if there are any. So when you look at this function, which is f of x, this one is 2x squared plus 1 over x squared plus x plus 4. First thing again I would see is, can I factor it, reduce it? You can't. So then I would start with the vertical asymptotes, which come from the bottom. So if I say x squared plus x plus 4 equals 0, that's not factorable. How do I solve it? Quadratic formula. So a is 1, b is 1, and c is 4. Negative b plus and minus the square root of b squared minus 4 times a times c, all over 2 times a. Negative 1 plus and minus 1 minus 16 over 2, which is negative 1 plus and minus the square root of negative 15 over 2. As soon as you get there, you should recognize that there's a negative underneath that root, and we cannot graph imaginary numbers. So there's no vertical asymptotes here, which is the answer for this one. The horizontal asymptotes, and because that's the case, it's continuous, which is B. Okay. The horizontal asymptotes come from looking at the highest exponent and the highest exponent. They're both the same, which means it's a leading coefficient. So y would be 2 over 1, which is y equals 2. And that's your vertical asymptote. So if I was to graph this, the only asymptote I have, I'm sorry, that's your horizontal asymptote, is here. And then I would have to find zeros and plot some points. Most likely these kind are going to pass through there. You just have to figure out what the curve looks like around that. I'll tell you right now on your test, you're going to get 2 of the 3. So you'll have some other guidelines. You'll either get a horizontal and a vertical, or a couple of vertical and a horizontal, or a slant. And so you're going to get at least 2 of those 3. You can't have all 3, which we'll talk about today. But you're going to get at least that, so it kind of helps you with your ranges. Okay, and then number 6 said find the asymptotes and holes in the graph of the rational function. Verify your answers using a graphing utility. And then enter the format of it. So vertical asymptote, again, comes from the denominator. So I would first see if that's factorable. So 0 equals 7x squared minus x minus 8. If I do first and last here, 7 times negative 8 is negative 56. Factors of negative 56 that sum up to negative 1 would be negative 8 and 7. So then I plug those in, 7x squared minus 8x minus 7, or plus 7x minus 8, and then factor by grouping. I could take out an 8, an x, 7x minus 8, and this one is already the same inside. So my factors are 7x minus 8 and x plus 1. So that's my denominator. When I put that under, and I look at my numerator, that's also factorable. This is x plus 1 times x plus 1. This is a case in which one of my factors cancels out, which means I lost the vertical asymptote there, but I also created a hole. So by doing that, I know that there's a hole wherever this equals 0. So at -1, there's a hole. Then I can get my other vertical asymptote from 7x minus 8. So 0 equals 7x minus 8, which means 8 equals 7x. X equals 8 over 7. That's my other vertical asymptote. I lost the other one, but this is still a vertical asymptote. So that went here, okay? And then the horizontal asymptote, I look back over here. The exponents are the same again, which means my horizontal asymptote is the leading coefficients 1 over 7, which is this one. So if I were to go graph that, I'd start with x equals 8 over 7, which is in between 1 and 2. And y equals 1/7, which is obviously just bigger than 0. Then if I'd have to look for intercepts. So if I set this equal to 0, I get x equals -1. But at -1, there's my hole, right? So that spot gets a hole instead of an actual point. So if I were to plug in -1 for the x, I would get 0, which means there's a hole here, okay, at -1, 0. So my graph is going here. And I would know that if I wanted to like plug in 1. So 1 squared plus 2 times 1 plus 1 over 7 times 1 squared minus 1 minus 8. And I get 1 plus 2 plus 1 over 7 times 1 minus 8. That's a 1. So 6 minus 8, which is -2. So this point here, okay, is 1, -2. And then I would need another point from the area that is to the right of that asymptote. So bigger than 8/7 could just be 2. So I'd get 2 squared plus 2 times 2 plus 1 over 7, 2 squared minus 2 minus 8. And that's 1/2, which is bigger than 1/8, because or 1/7, which is what's already there, which means it's right here. So your test is going to put it all together. It's going to ask you to identify any vertical asymptotes, horizontal asymptotes, slant asymptote, which we're going to get to today, holes, x-intercepts or zeros, and then y-intercepts. So it asks you to graph this using a graphing utility. You won't have a graphing utility on your test, but I want you to understand what happens when you do this. So I graphed it. I'm just going to... Okay, so when you graph it, so this is my function, y equals x squared plus 2x plus 1 divided by 7x squared minus x minus 8, which of course you have to group your numerator and your denominator so that it knows it's a fraction. And then when you click graph, you get here. Do you see a hole in this function? Your graphing calculator will not catch it. You have to know what's there. It eliminates the other asymptote, right? Because technically there should have been an asymptote at -1 and at +1, the vertical asymptote. So it eliminated that one, but it does not put the hole there. You have to be smarter than your graphic calculator. Sure. Does that make sense? Yeah? Okay. Questions on anything else related to the homework? Okay, so we are going to... It'd be negative... Go ahead. Keep going. Negative infinity. That's -1, so.
That's -1, right?
Yep.
And then it would go negative, then -1 to 1.
So that, I think it was,
And that one just squared.
the next 0 is 8/7.
So how many?
Yeah. And then 8/7. The whole on this one was at -1. Yep. Questions? And like you won't catch it and you'll be chugging along and you'll be drawing those vertical asymptotes and think you're doing good, right? You missed half the problem because there was a hole there. And if there's a hole, it changes your entire graph because it eliminates that vertical asymptote. So instead of there being 2 vertical asymptotes here and a horizontal asymptote, you'll be plotting points. You'll get super confused because you're going to get stuff here and then you're going to get stuff that goes like this and then you're going to get stuff that goes like this. And it won't make any sense. And that's why. So be really, really careful. Finish the notes. So what's left in, it's actually in 2.7. I put them together because a lot of it overlaps. But what's in 2.7 is slant asymptotes. Okay? So a slant asymptote occurs when the degree of the numerator is 1 more than the degree of the denominator. So if the exponent in the top is 1 more than the exponent in the bottom, the highest exponent, if it's 4 and 3, there's a slant. If it's 2 and 1, there's a slant. If there's 1 and nothing, there's a slant. Because the numerator's degree is higher than the denominator, which means there's no vertical asymptote, no horizontal asymptote. You cannot have a slant and a horizontal. Does that make sense? Okay, again, you can't have a slant and a horizontal. You can have a slant and a vertical, you can have a horizontal and a vertical, but you cannot have a slant and a horizontal. Because by making the degree in the numerator bigger, you're already eliminating the horizontal asymptote. So the way you find the slant asymptote is by taking what's in the numerator and dividing it by what's in the denominator. You might have to use long division. You might be able to use synthetic. And your equation comes from the quotient part of your answer. You totally disregard the remainder. So if you're dividing long division, then whatever's on the outside gets divided, whatever's on the inside. Your answer is y equals whatever's at the top. And again, you disregard the remainder. If you're using synthetic division, then you've got the number on the outside. You've got your terms here, 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 here. This is your remainder. You're going to ignore your remainder, and you're going to set y equal to whatever's left on the bottom, which has to be an x to the first power, thus the one in the numerator being 1 more than the one in the denominator. So slant asymptotes are always lines just like vertical and horizontals, but they obviously have a slant. You totally disregard the remainder. Okay, so it says find the slant asymptote of the function f of x equals x squared plus 6x plus 2. So the first thing I'm going to warn you about is that it's not going to say find the slant on your test. It's all going to be grouped together. You're going to get a function. It's going to say find whatever, vertical, horizontal, and if there's none, you put none. But the slant you have to catch. So you know it, again, by looking at the degree in the numerator and seeing that it's 1 more than the degree in the denominator. Do we see that? Yes? Yeah? Okay, so now we divide. Can I use synthetic on this one? If x is by itself, it's really what? Plus or minus 0, right? Yeah? Can you divide that synthetically? When do you know you can't divide synthetically? When must you use long division? When it's a or. You can't even do it if it's a. It could be just 2 terms, but it can't be what? So she said trinomial, which is true because it would mean there's something that's squared and there's something that's not squared. But does it have to have 3? What if that said x squared minus 1? Could you use synthetic?
Yeah.
Nope. You cannot divide synthetically if you're dividing by something that's raised to a power bigger than 1. It has to be x plus or minus something, okay? So if you don't know that, does that make sense? I mean, I said it 8 million times, but...
You can use long division,
Right. So the question is, can I use synthetic here? You can use long division every time, and you're going to be forced to use long division sometimes. But this one, you could actually use synthetic. So you could do both, okay? So if I'm dividing this synthetically, then 0 is going on the outside, and 0 doesn't have a sign, so it doesn't matter if it's positive or negative. And then my coefficients here are 1, 6, and 2. I bring down the 1, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it. I don't even care what this is. It does not matter. What I need is this. The 6 gets the nothing. The 1 gets the x, which means my slant asymptote is y equals x plus 6. If you did that long division, then it would be x plus 0 on the outside, x squared plus 6x plus 2 on the inside. This would be x, multiply it out, x squared plus 0x. Change your signs. This is gone, 6x plus 2. This would be plus 6, multiply it out, 6x plus 0. Change your signs. This is gone. Again, doesn't matter what that is. This is my slant asymptote. You with me so far? Does this one have a vertical asymptote? Is there a variable in the denominator? Can that variable be made 0? Then yes, right? Vertical asymptote here would be x equals 0. So you would have a slant and you would have a vertical and you'd have to pick points, which I'll show you in a second. But keep that in mind. Okay, so this one just said to find the slant on your notes, but we're going to keep going. We're going to find the points and all that good stuff. God bless you. All right, everybody get it there? Sure. So again, this had to do long division. This time you were missing terms in your numerator, so you had to add in the 0x squared and the 0x. All the rules of long division still apply. And then once you divide, you get y equals x minus 2. That's your slant asymptote. Everybody with me so far? Yeah? Okay, so I'm going to keep going so that you can see what happens when there's a slant. What about a vertical asymptote? How do I find it? Got to set the denominator equal to 0. This is factorable. Are there factors of 2 that add to 2? You got 1 and 2, right? Or -1 and -2. Neither of them add to 2, which means what? You got to do the quadratic. So A is 1, B is 2, C is 2. As soon as you get that negative, this tells you what? There's no vertical asymptotes, okay? So this graph would have only had a slant asymptote. It would have only been at -2, which would have been here. Like I said on your test, you will get ones that do have either a vertical and a slant or horizontal and a slant or multiple vertical and the combination of those. So let's just say this did have a slant, a vertical asymptote. Let's say it looks like this, okay? These graphs with slant asymptotes make an X. And when they do, your curves either go here and here, or they go here and here. And the way you would find that is by the zeros or plotting points, okay? So let's say this did have vertical. I could keep going here, and I could say that x to the third minus 1 equals 0, x to the third equals 1, x equals, that would be the cube root of 1, which is 1. So this actually has a point here, okay? And again, I would know that that means that my curve is the green on the left. Obviously, it has to run through 1. It would be there, and then I would plot a point to the right of my vertical asymptote, and I would have my other curve. This did not say it, but I just want you to think hypothetically, because you are going to obviously have these. What would happen if I had a vertical and a slant? You got to figure out which of those corners they go in. And they're always opposite. They're not going to be next to each other, so they're always opposite corners. Questions so far? Okay, so this last example, find the horizontal, the vertical, the slant asymptotes, and holes, graph the function, and then use a graphing utility to verify. See how far you can get on your own. All right, so the first thing I did on it was factor the top and the bottom, see if they're going to cancel out to give me a whole. Okay, numerator would have been x minus 4 and x minus 1. Denominator would have been x plus 2 and x minus 2. Nothing cancels with mean there was no holes. So that was the first thing I answered. Okay, you always want to check for those because it's going to cancel out and changes the entire function thereafter. Okay, so there's no holes there. Then for the horizontal asymptotes, I look at my numerator, my denominator, highest exponent in both was 2. This is your leading coefficient test. So this would be y equals 1 over 1, which gives you y equals 1. Everybody's good on that? Yep. Then I went vertical asymptote. So I set my denominator equal to 0. I had already factored it, so I could just solve it. And I get that x equals negative 2 and positive 2. So I've got one horizontal, 2 verticals. Okay? And the exponent in the top is the same as the bottom, which rules out the slant. Remember, slant, the one in the top has to be one more than the one in the bottom. Then came the zeros. So I set my numerator equal to 0. I solved it, and I got x equals 1 and x equals 4. I'll tell you right now, your zeros might be with the quadratic formula. So when you give me an answer, if it's not a whole number, you're going to give it to me as like reduced as it can. So it might have a square root in it. But when you go to graph it, you're going to have to approximate it. Okay? So those are your zeros. And then the y-intercept comes from plugging in 0 into x, which is 0, negative 1. So if I plot all that information, that's my vertical asymptotes, my horizontal asymptotes, my 0, which is zeros, which were 1 and 4 here and here, and then your y-intercept even, which is right there. This is not a symmetric graph. If you test it out, you'd know that, okay? Which means what happens on the right is not going to happen on the left. If I plugged in points, so I plugged in negative 1 to see what happened on this side of the graph, it went down to negative 4, or no, to negative 3 and 1/10. So I plot that point, and then I plugged in a point to the left of this asymptote, and I got here negative 3, and then what was that point? 5 and 3/5. So I plot those points, and I connect them to make my curve. These questions are worth a lot of points because they're stacked. Like it's multiple parts within a question. You need to be so careful. If you don't catch a hole at the beginning, the entire question thereafter is wrong. Because if there's a hole, it means you've canceled part of your equation out, which means it's a different graph. Okay? If you factor wrong at the beginning and then get the wrong zeros, again, the whole thing continues to be wrong. So you need to be very, very careful with these. Valentina, you have a question? Okay. Gia. You just set the numerator equal to 0. Because you could set it the whole thing equal to 0, but God bless you. You're always going to multiply by the denominator, always multiplying 0 by a denominator, which means it always cancels. So for the zeros, you just have to worry about the numerator. But again, after you check for the holes. Because if there's a hole, you've eliminated a 0. Questions? Okay, so your assignment is on WebAssign. It says part 2. Okay, I'll publish the part on Canvas now. My advice, again, is to make sure you are graphing these by hands before you select anything that might be multiple choice because there will be no multiple choice on your test. You need to know how to graph this stuff by hand, okay? And then tomorrow we have math, but we'll review when we're here. Wednesday we'll review, and Thursday's your test. So that's the end of the content that's on your test. I'll also publish the review, so if anybody wants to get started on it, they can.